Hello, and welcome to In Praise of Raw Data, Rematerializing Astronomical Images using Sustainable Print Processes. So my name is Dr. Melanie King, and speaking next will be Dr. Claudia Mignone.
Astronomical images have a very long history of centuries and millennia with all sorts of graphical and artistic representation of scientific phenomena happening in the sky from all over the world. Then in the 19th century, the introduction of photography finally enabled astronomers to automatically record light coming from celestial objects. And that paved the way for a number of some of the greatest discoveries in the history of astronomy and astrophysics. In the mid-20th century, there have been some experiments with color photography using analog astronomical images. However, the way that most people image the universe and space has something to do with a number of events that happened around the 1990s. And those include the availability of digital detectors, the onset of the internet, and the development of digital image software for processing images. And right at that time, the Hubble Space Telescope was launched. And Hubble, with its stunning images that were processed for public consumption and readily made available on the internet, has contributed a huge deal to the way that the public imagines space and the cosmos. And then some 20 years later, JWST is truly Hubble's successor, not just for the great science it is enabling, but also for its role in contributing to shaping the public's imagination of space and inspiring audiences around the world towards astronomy and the fascination for the universe. Of course, with respect to Hubble, JWST observes well beyond the wavelengths of visible light, so into the near and mid-infrared domain of the electromagnetic spectrum. That caused a number of questions. So all these awe-inspiring images prompted questions online about how these images are made. These questions were already quite popular with Hubble, but they became even more popular with JWST over the past couple of years. So in our project, we decided to embrace these questions to explore how astronomical color images are made together with art and photography students. As a first research step to create our curriculum, we talked with JWST science image experts. We met with Joe De Pasquale and Alyssa Pagan, who are science visual developers at the Space Telescope Science Institute and are some of the people behind most of the JWST images that are available on the internet. And then we also met with Professor Mark McCaughrean, who is a JWST interdisciplinary scientist and has decades of experience processing infrared astronomical images. During these interviews, we combined our complementary perspectives to break down how astronomical images for public consumption are created. As an astronomy communicator, I am mostly interested in the chromatic approach, or the way through which astronomical images taken in different filters are combined by associating colors to each filter that are proportional to the actual wavelength in the electromagnetic spectrum. As an artist, instead, Melanie was mostly interested in artifacts, which are something that makes each image truly unique. So the key artifacts that we focused on in JWST images are summarized in this slide. In the first image on the top left, we see that the center of a very bright, highly saturated star appears as black. So that has to be manually removed. Then in the second image, we see the characteristic image of spikes that appears also around bright stars. And that is caused by the optical system of the telescope. And it actually depends on the telescope design. So it can be thought almost as a signature of the telescope onto the images. Then in the third image in this series, we can see another artifact that is caused by cosmic rays. Cosmic rays are highly energetic particles from deep space that impact the detectors. And here you can see them highlighted with little circles on the image. And finally, in the fourth image, in the lower right, you can see some striations that is known as readout noise in the background. After these research sessions, Melanie went into the studio to translate these astronomical imaging processes into photographic and printing techniques.
So for this project, this is a picture of the Carina Nebula. I wanted to use the image of the Carina Nebula because I was interested in the 6 pointed stars. The 6 pointed stars are an artifact of the James Webb Space Telescope. They're diffraction spikes, and it's because of the 6 mirrors on James Webb, so you wouldn't get this in a Hubble photograph. And it's very important for me to produce all of my images now in a sustainable way. This is done using the risograph process, which is a bit of a combination between screen printing and a Xerox or photocopy machine. So you have a master, which is cut out by the machine, which is based on the color separations that you do in Photoshop, very similar to how you would composite in astronomical imaging. And each of these lets a certain amount of ink go through the master, and you can do up to about 4 colors. The sustainable element of the risograph is the paper, so that's made out of recycled paper. The inks are from a soya base, so they're vegetarian. And the starch, the masters are made of starch, so they are completely biodegradable. Again, this is an image of pillars of creation, and you can see I've left in the overexposed cores. I find those really interesting as an artifact from the telescope. And again, this was produced using the risograph technique, but using only 1 color. And theoretically, it is possible to build up to 4 colors, but we weren't able to do this due to the availability of inks. And I made this in collaboration with Park Press, who are based in Margate. And then finally, this is an image of the Tarantula Nebula, which was given to me as an image from the James Webb Space Telescope Institute. And again, you can see some of the diffraction spikes on this image. This is a photograph that is produced using the screen printing process. And I worked in collaboration with a Birmingham-based photographer called Claire Hewitt, a botanical ink maker called Carolyn Morton, and a paper maker called Danielle Phelps. And they're working together to produce the first sustainable photo book. So we used a ink which was made from oak gall. So if you're not sure what an oak gall is, they're made when a wasp goes into a tree, and it leaves this highly tannin-rich object behind, which you can then make into ink. It was then printed onto paper made from coffee cups, and also made paper using cotton remnants that had been recycled into paper. So just to end, I'm just going to talk about some of the pedagogical possibilities for this project and what we're working towards. The next step that I want to do for this project is to make a duo-color cyanotype. So a cyanotype is one of their most ecologically friendly photographic processes that you can use, but you can also build up color through toning and using different botanical dyes to change the color of the image. And the idea behind this is that it will be easily replicable. Students will be able to learn about astronomical imaging, learn about how the James Webb Space Telescope works, learn about raw data, and also learn about sustainable printmaking techniques. So thanks very much for watching. Thanks from myself and Claudia Mignone.